Hello, I hope everyone's doing well. This is part one of a two-part video on vector addition and vector subtraction. Your assignment is pretty simple. I want you to watch this video thoroughly, take good notes, answer the two practice problems in here, and then submit your notes and the practice problems in the Dropbox on Canvas. And please, if you need clarification or you need any kind of assistance, I want you to attend our online office hours so I can help clarify any questions you have. This discussion will continue as the weeks progress, and we're going to get more and more in detail regarding vectors. So about 4 to 5 weeks ago, we first introduced vectors to you, and we discussed the difference between vectors and scalars. And when we were talking about vectors, we came up with this definition of vectors. A vector is a measurement with a direction. So a magnitude with a direction. The word magnitude is synonymous to the word measurement. Just remember that. Whenever I hear the word magnitude, I think of the word measurement. Examples of vectors are displacement, meaning how far you are from where you were, so how much you've moved, your velocity, acceleration, force. Here are a couple of examples of adding vectors. So when vectors are pointing in the same direction, such as vector A that's pointing to the right and vector B that's pointing towards the right, and I'm asking you to add the two vectors. So the first rule of vector addition is to place them head to tail. So you can pick up the vectors and rearrange them so that they're touching head to tail. This is the head of the vector, this is the tail of the vector. So you can see I placed vectors A and B so that vector A's head is touching vector B's tail. Now remember, when you move vectors, you can definitely pick them up and rearrange them so that they're touching head to tail. What you cannot do is you cannot change their direction and you cannot change their size or their measurement. So in this case, when I've added two vectors, A plus B, this is the resultant vector. So this is the result of vectors A plus B. If I were to put numbers in here, so vector A is 4 meters per second and vector B is 2 meters per second. If I were to add them head to tail, this would be the resultant vector. The resultant vector is pointing towards the right, and the magnitude is 6 meters per second. Now, if I have two vectors where vector A is pointing towards the right and vector negative B is pointing towards the left, if I'm asking you to go ahead and add the two vectors, so A plus negative B, I'm going to follow the same rules. I'm going to rearrange the vectors so that they are touching head to tail. So vector A's head is touching vector B's tail. And the resultant vector is going to be this guy right here. This is going to be A plus negative B. The resultant vector basically fits in from the beginning of A to the end of B. So this vector is basically what's left right here. So this is the resultant vector. So if I had numbers to place in this example, vector A is 4 meters per second, vector B is negative 2 meters per second. If I were to add the two vectors, I place them head to tail, and this would be the resultant vector. So what's basically happening is something we discussed in class before. When vectors are pointing in the same direction, you just mathematically add them together. When they're pointing in opposite directions, you mathematically subtract them together, because in math class you've been taught when you have a plus and a minus together, it becomes into a minus. Now, when vectors are perpendicular to each other, such as this example right here, vector A is to the right and vector B is up. If I'm asking you to add the two vectors, you're going to rearrange them. You're going to place them in such a way so that they're touching head to tail, and this will be the resultant vector. And how do you find the resultant vector? You use your math skills. In trigonometry and geometry, you were taught how to use Pythagorean theorem. So you use a squared plus b squared equals c squared, and you're going to come up with this resultant vector. So if I were to put numbers in here, vector A is 4 meters per second, vector B is 2 meters per second. When I place them head to tail, this is going to be the resultant vector right here. The square root of 4 squared plus 2 squared, which comes out to be approximately 4.47 meters per second. Now, how do you find the direction of this resultant vector? Well, you find the direction by finding this angle theta, and I'll discuss that in the food for thought section of part 2 of our video. So in math class, you're taught how to find the resultant vector when they're perpendicular, because this is a right triangle. You're simply using Pythagorean theorem, which is a squared plus b squared equals c squared. So c is going to be the square root of a squared plus b squared. And one thing I want to emphasize, that I've been saying the word resultant vector. This is what I'm going to use. The symbol is what I'm going to use from now on. This symbol stands for the sum, and this is V for vector. So the sum of the vectors, meaning the resultant vector, in this particular case is going to be the square root of a squared plus b squared. And the final example number 4, I have vector A to the right, vector negative B is